Hey everyone, and welcome to today's Explainer. Okay, let's dive right into this, because today we're looking at a truly monumental shift in the global technology landscape. While the rest of the world has been intensely focused on Western tech giants, Alibaba's T-Head division has been silently, steadily, and honestly, really aggressively building something massive. They're creating a completely independent, sovereign AI stack. We've put together some really detailed infographics for this explainer, and we're going to use them to unpack exactly how they're pulling this off, step by step.
Actually, we're just going to skip the standard agenda today so we can look right at the immediate global stakes. Take a look at this side-by-side breakdown. The global AI market is, for all intents and purposes, functionally splitting into two totally distinct, non-intersecting ecosystems. Over on the US pole, you've got the familiar names, right? NVIDIA, Anthropic, Microsoft. But if you look at the right side of this infographic, anchoring the rapidly solidifying China pole, we have Huawei and, as we'll explore today, Alibaba's Zhenwu chips and their Quen models. It's a massive bifurcation. And to really grasp it, we first have to understand the sheer scale Alibaba has already achieved. So, let's get into Section 1, the Chinese AI Challenger. 560,000. Now let that sink in for a second. As of May 2026, that is the exact number of units from Alibaba's Zhenwu series that have already shipped. I really want to emphasize this point. We are not talking about some far-off future concept or a theoretical roadmap here. Over 500,000 of these units are currently deployed in the wild, actively powering real systems. Now, you might be wondering, who's actually using all those chips? Well, if you look at the data in this table, it's over 400 unique clients across 20 different industries. The social proof here is just absolutely undeniable. We're talking about deep, fundamental integration into crucial Chinese infrastructure. It ranges from telecommunications with China Telecom to automotive manufacturing over at Fei Group, all the way into high finance with Shanghai Pudong Development Bank. This isn't an experiment. It's a proven working ecosystem. Moving on to Section 2, inside the Zhenwu silicon. Okay, so let's pop the hood. The first critical spec to look at is 144 gigabytes of high bandwidth memory, or HBM. Now, in the AI world, memory capacity is literally just as crucial as raw processing power. You basically need a massive, hyper-fast workbench to hold the billions of parameters of today's gigantic AI models. Without it, the chip is just constantly running back and forth to slower storage, which ruins performance. Packing in 144 gigabytes puts them right there in the heavyweight class. But memory capacity alone isn't the whole story. You need blinding speed, too. And that brings us to 800 gigabytes per second of inter-chip bandwidth. To put that into perspective, that is enough speed to transfer dozens of full 4K movies in the literal blink of an eye. Because modern AI models are just way too big for any single chip, they get split across many of them. This incredible connection speed means data moves almost instantaneously, completely preventing bottlenecks and making sure those processors are never just sitting idle waiting around for information. Check out this bar chart infographic because it perfectly captures how aggressive this hardware scaling really is. The current M890 represents a staggering 3 times performance leap over their previous 810E model. And that's absolutely crucial because that's the exact evolutionary jump they needed to directly compete with NVIDIA's H20 equivalent in the Chinese market. And as you can clearly see by the trajectory on this chart, they are fully planning to do it all over again. Tracing their future roadmap on this timeline graphic, we move from the present M890 out to Q3 of 2027. That's when the V900 is planned to hit 216 gigabytes of memory and an insane 1,200 gigabytes per second of bandwidth. So another massive 3x jump. Then, looking ahead to Q3 of 2028, the Zhenwu J900 promises a fundamental architectural leap in parallel computing. The takeaway here, they are moving fast, and they're confidently publishing the roadmap to prove it. Let's look at Section 3. Building the AI supernode. The magic number on this slide is 128. Alibaba takes 128 of those M890 chips and connects them all together using what they call their ICN switch 1.0. This creates a supernode. Because of that incredible inter-chip bandwidth we were just talking about, these 128 distinct chips can functionally act as a single unified computer. The latency between them is measured in mere hundreds of nanoseconds. For all intents and purposes, it's instantaneous. So, why go through the trouble of building a 128-chip supernode? Well, the answer is agentic AI. This goes way, way beyond simple chat prompts. Agentic AI requires systems capable of massive concurrent agent inference.
Basically, that means thousands of AI agents working simultaneously and autonomously to solve really complex problems. This supernode system was purpose-built from the ground up to do exactly this.
Which brings us to Section 4, Closing the Loop, the Sovereign Stack.
Let's look at this step-by-step graphic to see how this all builds into a complete picture. First, at the bottom, you have the foundational hardware, the Zhenwu M890 chips. Second, you have the infrastructure layers scaling it up, the 128 supernode. And finally, sitting perfectly on top of it all is the software, Alibaba's very own QW 3.7 Max AI model. When you put it all together, it creates a fully closed-loop sovereign AI stack. Alibaba controls absolutely every single layer of the entire process. And the results of controlling that entire stack? They're honestly astonishing. Because Qwen 3.7 Max runs natively on their custom Zhenwu chips, the AI model was actually able to autonomously optimize its own inference workflow. It literally executed 11,580 autonomous tool calls to essentially rewire how it runs on the M8090 hardware. The result was a 10 times speed increase. Think about that for a second. The software is literally optimizing itself for the hardware it lives on.
And finally, Section 5, the Great Tech Bifurcation. Ultimately, Alibaba is widely considered to be NVIDIA's most dangerous competitor in China. And it's not just because their silicon is fast. It's because, as this quote highlights, they don't just sell chips. They sell a complete AI experience. It's a turnkey, fully sovereign ecosystem optimized natively by their own Qwen model. It's the whole shebang. And that leaves us facing a pretty stark reality. These ecosystems no longer intersect. The US pole and the Chinese pole are now functionally independent of one another. They're no longer relying on shared hardware designs, they don't share infrastructure models, and they definitely don't share software architectures. They are effectively two separate technological continents, each on their own completely independent trajectory.
Which leaves us with a final and, frankly, a very provocative question. What happens to the pace of global innovation when the world's two largest AI ecosystems completely stop sharing hardware and software? It's a massive, fascinating macroeconomic and technological puzzle, and it's definitely one we're going to be watching very, very closely. Thank you so much for joining me to explore this data today, and as always, keep questioning the world around you.